Hi, welcome back to Future Fast. And those of you who are here for the first time, I'd really urge you to go back and listen to the first part of our conversation with Dr. Adrian Blanck. And all I want to say with the second part of our conversation with him to you is that we are going to talk a whole lot of conversation of this part is going to be about energy and oil and gas. So you should go back and listen to the first part if you have missed it, so that you will have an understanding of where he is coming from. And for those of you who have not subscribed to Future Fast yet, please do it right now. Well, Adrian, thank you so much for being with us today.
Thank you very much. A pleasure being with you, Nanju, and with your auditors. Thank you.
Well, can you please talk about your current role as Chief Digitization Officer, and particularly in the context of how you see the challenges that you foresee in future that are going to have an impact on your organization pertaining to your role?
Yeah, so I'm the Chief Digitalization Officer for Saudi Aramco Base Oils, which is one of the many companies that are forming Saudi Aramco. So in this role, it's a very, very interesting role. So what I'm doing, I'm looking at different pieces of technology that can be brought to this industry to improve the overall efficiency of what we're doing. So when we look at improving efficiency, just to clarify something, I'm working in what we call the downstream oil and gas, which is the part that takes the crude that comes off the ground, and we are transforming it into various useful molecules. That's what we call the downstream part, refining and transformation and marketing those molecules. But the biggest part of this industry is the refining. So you're taking the crude from the ground, you refine it, and you transform it into either fuels or other raw materials for the petrochemical industry. And I think it would be useful to talk a little bit later on about the future of this industry, because even if we manage in some distant future to get rid of fossil fuels completely, we will never be able to get rid of the petrochemical industry, which manufactures the myriads of materials that we are, at this very moment when we're having this podcast, we are surrounded with. Everything that we are looking at on the desk, in our computers, in our telephones, in our whatever, is a product of the petrochemical industry and the chemical industry.
Well, Adrian,
yes.
Sorry to continue. I keep hearing this part that we can have an end to the fossil fuel, but there can never be an end to the petrochemical industry. Can you just explain
Correct.
that? Maybe we'll get back to it. I think I jumped the gun. I'm sorry. We'll get to that question after you talk about your role.
The short answer is our modern world cannot function. And I am very precise about this. It cannot function without petrochemical products. Everything that is just, if you look around on your desk now, everything you see, from the plastic materials that your monitors are encased in, the cables, your computer materials, everything is a product of petrochemical or chemical industries.
That's
Our
right.
modern
Adrian,
world cannot function without.
I'm sorry. I think we'll go with the flow itself. Maybe you could explain in terms of. We'll come back to this question. I think I just got carried away. So what does digitization mean in downstream of this? How does that work? Because traditionally, digitization we attribute to in so many very ways. But digitization in the downstream, in petroleum industry, how does that work?
Well, it works in a fantastic way, because this industry is a very old and mature industry, and a typical refinery which is normally connected or not necessarily directly connected, but in most cases, the two work together. You have a refining and a petrochemical plant that are normally under the same umbrella, sharing the same space. These plants, they churn out an awful lot of data. Our industry, although generates a lot of data, was not one of the early adopters of digital technology, because whenever you have a lot of data, that data can or should be put to some good use, whether you are using the data to help making better decision management or better production decisions, or you use it to make advanced predictability decisions related to your maintenance or your engineering activities. But in our industry, as I said, we were not early adopters of digitalization. So when you look at data usage and digitalization in this specific industry, there are 5 or 6 different verticals that we can conceptually think in terms of bringing data and digital technology to improve how things are done. The first one, obviously, is logistics. You have some fairly complicated logistics for both raw materials and for the finite or semi-finite products. Here, the main complication comes from the different types of crudes, different types of petroleum grades that you're working with, and the sheer size of it. Because for this line of business, everything is measured in shiploads. Hundreds of thousands of barrels of raw material that are processed every day. The typical size for a refinery in our world would be 500,000 barrels a day. And that's a shipload. So you can utilize digitalization for logistics, for improving your supply chain. You can use it for your operations and your engineering part. You can use it for improved decision-making in both the way you structure your supply chain and your operations and engineering. You can use it for better maintenance decisions, going into predictability and preventive maintenance, etc. You can use it on the commercial side for improving the way you interact with your customers and the way you sell your molecules. And you can also utilize it successfully on the HR part. So these would be the 5, let's say, verticals that you would normally consider bringing digitalization into in our world. And then it's a matter of finding useful use cases and building a business case for each of these particular things, and then transforming them into reality on the ground. So just to give you an example, I was significantly involved in developing an application that brings financial information to the operators in a refinery who have their finger on the profitability of the company. Traditionally, at that level of organization, people had no financial information whatsoever. So we designed applications that take all the data, both physical parameters and business information, from the various systems that are working with this kind of data, use some advanced algorithms to do some predictive, to generate some predictive hypothesis of profitability, and we bring that live to the operators who sit in the control room of a refinery, who can dictate how much or how profitable, or how much money that particular part of the company is making, which is, a fairly new way of looking at this business. Also, one thing that I just want to highlight here, as I said, this line of business, refining and petrochemicals, it's an old business. It's a very mature business, and digitalization is perceived as one of the remaining ways of generating or collecting the last cents off the table, because we have refineries that are working for the last 100 years, and pretty much everything that had to be invented from an engineering standpoint kind of was invented. There are very, very few engineering breakthroughs that have been brought to this line of business in the last, let's say, 20 years. Actually, as a matter of fact, we are working now on a very advanced way of doing what we call hydrocracking, which is basically adding we are adding hydrogen to various molecules, and we are looking at something that's totally new. So if that works, it works in laboratory. We are now testing it in the field. If that works, it will be probably the first major technological breakthrough in this line of work for the last, I would say, 25 years. But going back to the original point, yes, we see digitalization as a way to grab the last cents that are left on the profitability table in an industry where constantly improving and bringing efficiency and operational excellence to the shop floor is, the essence of business for 50 years. So not a lot of improvements that can be brought, but digitalization is arguably the most important of them.
Right. Well, thank you. Now, just getting it one step back into where I had to ask you to stop about the petrochemical industry. How do you say petrochemical? I mean, of course, everything is made of plastic. Everything plastic come from petrochemical industry. But when we run out of fuel, how will petrochemical as an industry be still on? Because fuel is an offshoot of it, right? How does, I mean, this is a comment I keep hearing, that petrochemical industry will always be there. So I was always curious, I mean, how?
Well, obviously, at some point in time, the oil will run out. So we're
Right.
going to run out of oil and gas. We don't have yet a good scaling and sustainable answer to that. We can manufacture synthetic fuels. The petrochemical industry, in essence, works with two products. One is called ethylene, one is called propylene. And these two, so ethylene and propylene are the raw materials for the petrochemical industry. Ethylene is typically produced through what we call cracking the ethane. So you get the gas, and then you put it into a cracker, which is a device, a reactor, where under heat and pressure, the gas breaks into different components, and you get ethylene. The other one is propylene. So these two raw materials, they go into different reactors, and they produce what we call polyethylene and polypropylene. And polyethylene and polypropylene are the main feedstock materials for the myriads of plastics and rubbers and materials that our modern world is made of. Now, you can make them in a synthetic way. So you can, in a world where you have an infinite amount of energy, which is the fundamental problem of our world, because our world is anything but having an infinite amount of energy. Actually, we're struggling to provide enough energy to power today's needs, where, about 70% of the energy we generate today is generated by burning fossil fuels of some kind, either coal or gas or oil or wood. So in a world with infinite energy sources, you can combine these molecules. You can take hydrogen from water. You can take carbon atoms from wherever the carbon is plentiful in this world. And basically, you can engineer all these substances. The problem and the reason we are using fossil fuels today is that producing them requires an awful lot less energy than engineering them through individual molecules of hydrogen and carbon and adding whatever other molecules that are needed, like, I don't know, chloride or phosphorus or sulfur or, you name it. So the fundamental problem is the amount of energy that we have at our disposal. Just to put things into perspective, because you've touched on this issue before, the world today, last year, so if we're taking 2022 data, we used 22,500 terawatt hours of electricity. So 22,500 terawatt hours of electricity. Now, about 70% of that, 68 to 70% of this electricity was produced through combustion of fossil fuels. So combustion is an essential aspect of our modern world. Combustion works by burning things. The problem is that when we burn things, those things produce carbon dioxide and a bunch of other gases, but we have a fixation on carbon dioxide, and we say, and this is the generally accepted theory of today, carbon dioxide is bad, therefore carbon dioxide should be reduced to a maximum and eventually phased out completely. Because burning fossil fuels produce carbon dioxide, fossil fuels should be phased out and eventually replaced. So now, if we want to replace that 70% of 22,500 terawatt hours of electricity that was generated using fossil fuels with, let's say, something else, what's the order of magnitude of that something else? We can replace it, let's say, with nuclear power, which is the most sustainable and scalable and dispatchable and load following source of energy we have today. If we want to replace it with nuclear power, we need to build one nuclear reactor of the latest design that we are making now in Europe, which is the EPO, the EPR, the European Pressurized Water Reactor, of 800 megawatt hour electric. So we need to build one reactor every 2 days. Okay, that's the order of magnitude. And we need to do
for
this.
How long?
Until 2050
Wow.
to replace. Yeah, so that's the order of magnitude we're talking about. Now, let's say you don't build nuclear reactors. So it's one reactor every 2 days. Actually, the more precise calculation is 2 reactors every 3 days. 2 reactors of 800 megawatt electric capacity, operating at 93% mechanical availability, year in, year out, throughout 2022 to 2050. If we are to build wind turbines, let's say the wind turbines of 5 megawatt capacity, which are not the biggest ones we have. I think now we have 10 megawatt wind turbines, but most of the ones that are installed, let's say in Northern Europe, are 5 megawatt. So if we had to build wind turbines to compensate for that loss of electricity coming from fossil fuels, we need to build 1,500 a day, 1,500 wind turbines of 5 megawatt a day, every day, day in, day out until 2050. So when you see that, you clearly understand that fossil fuels are there to stay. There is no way we can replace them. We can make a big discussion about the role of carbon dioxide and how we can phase them out, but the sheer reality is that there is no alternative. And this is one of the things that I'm insisting in all the discussions and all the presentations.
What about the argument of this running out?
They are running out. The thing is that eventually we need to replace them with something. The question is, what do we replace them with? And of course, electricity is probably the energy of the future. The problem, the fundamental problem we have today is that for electricity to become the energy of the future, we need technological breakthroughs in two areas. One, which is the most important one, is our capacity to generate electricity, because, as I said, most of the electricity we generate today, we generated it through combustion. So we need to replace combustion with something else. What can you replace combustion? Well, you can replace it with nuclear, or you can replace it with renewables. If you replace it with renewables, the order of magnitude of renewable replacement is of 1,500 turbines a day. So that's impractical. It's impossible. If you want to replace it with nuclear, then we need to be able to build nuclear at scale. And we lost the know-how in the developed world to build nuclear plants at scale. The other thing that we need is a breakthrough in electricity storage. For the world to run on electricity coming from renewable sources, we need to have 6.5 hours capacity storage, electricity at grid level, globally. Right now, we have 75 seconds. So if you add up all the storage, all the electricity storage capacity in the world, it ends up to a minute and a bit. And we need 6 hours of storage. For the world to function as we know it today, when the 8 o'clock train starts at 8 o'clock, it doesn't start at 8 o'clock if there is wind blowing, or if there is sun shining, or if the overall demand coming from the residential sector is not high enough. Our world is built on energy being available. You flip the switch, the light comes on. Now, that's not necessarily true everywhere in the world. We have lots of places in the world where when you flip the switch, nothing happens because there is not enough energy, there is not enough electricity in the grid to power the needs of businesses or individuals. So the first breakthrough that we need is our capacity to build power plants at scale.
What about
the other
solar?
Breakthrough?
Are there any
Solar
such numbers
has the
for
same
solar?
issue. I think we ran a simulation back in the day when the Desert Tech project was instrumented. So that is probably 9 years ago. If we had to replace the part that, these, let's say, 17,000 terawatt hours of energy that are missing, that are coming from fossil fuels today with solar panels, we would need about 12,000 square kilometers of solar panels installed somewhere. But the problem is not for renewable energy. The problem is not as much generating renewable energy, because we know, okay, if we put enough wind turbines out there, but we need an awful lot of wind turbines and an awful lot of solar panels out there, they will generate electricity. The problem is, how do you use that electricity? Because you have no possibility to vary the output of these things. A wind turbine generates electricity, and the output varies with the cube of the wind speed. So the amount of energy that's electricity that's generated is nothing but constant. Now, the grid requires very, very close monitoring of both tension and amperage, but most importantly, the frequency. Two grids cannot be connected to each other if they are out of sync. So for the grids to be in sync, so you can shed power from one region to another, which is what happens in our integrated European grid, those grids need to be in sync. This doesn't happen, for example, in North America. The US, although it's a developed nation, highly developed nation, operates with three grids completely separate. You have the Eastern Seaboard grid, Western Seaboard grid, and Texas grid. These three grids are not integrated because they are not operating on the same frequency. Their frequencies are slightly different, and because they are slightly different, they cannot be synced together. That was one of the reasons that, you know, the Texas had the problems they had with both cold weather and very hot weather in the last years. So it's not an easy thing to do. You can generate power with renewables, but to generate it in a useful manner, it's a totally different thing. To have it as a useful
how
power,
do you
need
propose
to
we
store it.
address this?
We need a breakthrough in battery storage. Unfortunately, we don't see anything at the horizon.
Right. Adrian, help me understand. It's always referred to as renewable being more sustainable, right? But sustainable.
Excuse me, can you repeat? Can you repeat?
Renewable being more sustainable, renewable energy being more sustainable.
More
Correct?
Sustainable than what? That's a highly debatable statement.
Right.
It needs qualification. More sustainable than what?
More
sustainable than
fossil fuel.
Than fossil fuels. Well, it is more sustainable in that if you take a solar panel, that solar panel produces energy without any carbon dioxide emissions, right? The problem is that that particular solar panel in it itself is not going to provide an awful lot of good, because it provides electricity not when you need it. It provides electricity when the sun shines on it. Now, we need electricity not only when the sun shines. And to have that solar panel useful as an electricity source, it needs to be backed up by something that provides electricity when sun doesn't shine.
Correct.
To back it up, you can back it up like Germany's doing. They back it up. No, well, that's the problem. You can't back it up with storage because we don't have storage technology. Germany and the world in general backs renewable sources up with conventional energy sources. So Germany is backing up with coal-fired plants. They used to have them backed up with gas-fired plants, but now gas being curtailed from Russia, they had to fire back a lot of coal-fired plants. The rest of the world is backing them up with whatever base load electricity we can have. And base load is mainly coming from coal, gas, nuclear, hydropower, and coal. That's the order of magnitude for the backing of renewable sources. The other problem that you have with renewable sources is that you cannot have, in a given grid, with the technology we have today, you cannot have an infinite amount of renewable electricity, because sooner or later you run into major issues controlling the frequency of the grid. Because, as I mentioned before, that electricity that's coming from renewable sources is anything but constant. And our grid and all the electric appliances that we have require constant frequency. If the frequency of the electricity that you have in the grid varies by more than 1.3%, then some very nasty things happen. You don't want that to happen because that destroys the grid. Therefore, the frequency of the electricity of the grid has to be controlled at all times. You cannot control the frequency if more than a third That's the case in Europe, by and large, with the energy mix that we have today in Europe. We can't have more than a third of the total European grid powered by renewable sources because we cannot control the frequency of the grid anymore. So if you want to produce renewable electricity and use it in the grid, you need various forms of either backup or storage. Backup
so what happens
requires,
to net zero goals then?
well, net zero is an aspirational target at best, and it's part of the fallacies that the society has come up with. It sounds great in reality. It has nothing to do with practicality.
Every government has set very definitive goals, right? When India said our net zero goal is 2070, many people said
Yes.
Europe, UK, US, and all are much shorter time. So India is not truly committed because we are talking about 2070. We are not saying 2050.
Yes, I think India is very smart about these aspirational goals. And I think, unfortunately, Europe is heading straight into a wall when it comes to the carbon dioxide regulations that are hampering our economy. There was an article in Financial Times 2 weeks ago about Germany starting to go through a de-industrialization process. So Germany, which is probably arguably the most successful economy of the world, going through a deindustrialization process because Germany is not capable of generating enough energy. And Germany is not able to generate enough energy today because of carbon dioxide emissions, its utter reliance on renewable energy, and the fact that the vast majority of gas that Germany was importing from Russia, which was supposed to compensate their decision to shut down the nuclear power plants, the whole nuclear sector in Germany, is now yielding very nasty consequences. So unfortunately, from my standpoint as an energy expert, what I see as policymaking in the developed world, especially in Europe and the US, in terms of carbon dioxide, Green Deal, energy sustainability, is nothing but sustainable. I've never seen this much wrong policy making in the 30 years that I'm working in this energy field.
How do you address this? I mean, there are so many not-for-profit agencies, everybody's, and there is so much of narrative about it. So how do you address this?
I think the first thing that needs to be addressed is the elephant in the room. And people need to start, energy experts need to be brought to the table when policy is decided. And we need to say, look, it's impossible to get rid of fossil fuels by 2050. It's impossible to get rid of fossil fuels by 2070. It's impossible because there are technological limitations of various kinds. If we want renewable energy to be useful, we need a breakthrough in energy generation and we need a breakthrough in electricity storage. There is no significant breakthrough in electricity storage in the last 20 years. There is a potential avenue that's currently being explored. It's called the liquid metal battery. That's pioneered at MIT, was pioneered at MIT, but by Professor Donald Sadoway and his research team. And now it's been transformed into a corporation called Ambri. These guys, they started from the assumption that none of the battery chemistries that we have today are sustainable for a variety of reasons. Lithium, not enough of it to go around if we want to do mobility based on electricity, based on stored electricity using lithium-ion batteries. Other materials that are required for lithium-ion batteries like cobalt, not abundant enough to sustain it on the long term. Therefore, the lithium-ion avenue, not sustainable enough. And they started from the assumption that if we want an electric future for mankind, we need storage, and we need batteries to store, and we need batteries that are made of dirt, cheap, and abundant materials. Hence, they came up with the idea of using abundant metals like bismuth and magnesium initially, use them in liquid form, and have them put together in a battery that works in a slightly different way from your regular battery works. As a matter of fact, they reverse the chemical process that happens in an aluminum smelter, right? Aluminum smelter is a device which uses an awful lot of energy to refine aluminum. The liquid metal battery is using molten metals like bismuth and aluminum or magnesium to store electricity. So this is the only major breakthrough in battery chemistry that has the potential of altering the storage conundrum, the electricity storage conundrum. Going back to your question, what we need to do, we need to bring back nuclear energy big time. We need to bring back nuclear energy as the only sustainable and scalable form of energy we have today. We see China and India being at the forefront of the civilian nuclear revolution of today. Unfortunately, in the Western world, we completely lost the know-how of building nuclear power plants at scale. And that is simply because in the last 35 years, we haven't built anything in Europe. We're struggling to build 2 nuclear reactors now, very modern reactors, totally generation 3, as we call them, using some very advanced technology, which is different from what we had so far. But the reactor in Flamanville is under construction for 12 years now. There is another one in Britain at Hinkley Point, and that is also under construction for a significant amount of time. And these 2 are the only examples of the developed world being nuclear reactors. And when I say we lost the know-how, it's because we haven't built anything in the last 30 years. So the average age of the engineers and technicians working in Flamanville is 63, 64. So we had to call back from retirement a lot of people to face the engineering challenges from a human standpoint. Then so bring back nuclear, invest a lot more in nuclear fission and research, develop novel avenues of nuclear fission, which go away from the current philosophy of using enriched uranium. So we're using uranium-235 as a nuclear fuel. We should be starting to get into using thorium and moving away from the enriched uranium avenue, which is an afterthought of building nuclear weapons. Because nuclear industry, the civilian nuclear industry, is a byproduct of the Manhattan Project. We didn't build nuclear plants to make electricity. We built nuclear plants to make fissile material for atomic weapons. And unfortunately, that has continued today. Using thorium will be a breakthrough initiative in that we move away. You can't produce fissile material from thorium. And that is one of the main avenues that are explored today. Unfortunately, they are not put into engineering practice. So bringing back nuclear and building nuclear at scale is the first and most urgent thing we need to do. At the same time, we need to invest a lot more in battery chemistry research and try to come up with a breakthrough in battery chemistry. The molten metal battery that I mentioned, that's making that is manufactured by Ambri, is still not.
It's already in the market.
Yes, it is in the market, but Don Sadoway is struggling to bring it to a competitive price point compared to lithium-ion batteries. They say within the next 10 years they might bring it back to the level of lithium-ion battery storage cost per megawatt of today. We'll have to see that. But there is a fundamental drawback to that. It can be used for grid storage. Actually, this is how the battery was designed to be. It's designed as storage for the grid. It cannot be used in mobile applications for a number of reasons that have to do with how the liquid electrodes interact with each other. So even if we have an answer with this for grid storage, we don't have a suitable answer for electric mobility based on batteries.
Anybody
so
else
what
you think
I am maintaining? No. There is a lot of talk, but there is nothing of consequence that comes out.
What about in Europe?
There were nothing. There was a big piece of news the other day coming from Toyota saying that they engineered a new type of battery, but we keep hearing that for 15 years now, and we haven't seen anything other than press releases. And it's the same thing as Lawrence Livermore Laboratory in the States announcing that they achieved ignition, fusion ignition, which is true but not true. And it was it was just picked up by media and made it into a frenzy, and everybody was assuming that the technology that they're using now can be used to make fusion energy. No, it cannot. I mean, it can make energy, but you consume almost an order of magnitude more energy than what you're producing by igniting that pallet of fuel. So no, unfortunately we don't see anything at the horizon today other than the Ambri battery that gives us hope that battery technology will evolve in a different way, and it could be sustainable for the long term. Even for electric mobility, the lithium-ion option is not sustainable on the very long term. It can provide mobility solution for a number of decades, but it's not sustainable going forward if we're talking about the next 70, 80, 100 years. So we need to invent something else.
If you have to give shout out to entrepreneurs and technologists to work on, what would that be? What areas you want them to look at?
I think what Elon Musk is doing with electric mobility is revolutionizing the sector. I think Tesla is a very neat machine, and the kind of energy density the Tesla battery is definitely the technological marvel. The energy density and the way it maintains its parameters and energy density in time, it's absolutely remarkable. I also think what Professor Sadoway has done with the Ambri battery is absolutely remarkable. These would be the two major, the two key things that I see as breakthroughs in this front. On this front, there is another technological innovation, which is basically using nanotubes of carbon. Actually, it's atomic carbon, graphene, to produce electricity. That is also something that is definitely worth exploring, and I think there are quite a number of nanotechnology material departments at leading universities in the world. So we were talking about different leading avenues for technological breakthrough. So I mentioned Elon Musk and Tesla, yes, and research into nuclear fusion into the more realistic way we could achieve nuclear fusion, the type of experiments we are running today in Europe and in southern France at Cadarache, part of the ITER project, which is the largest tokamak in the world, attempting to produce commercial nuclear power in the next 20 years. I think that is something that we have to do more. I think there are interesting avenues to explore in the use of carbon nanotubes, graphene nanotubes, in which the thermal electric effect manifests itself in a very, very peculiar way. So basically, the thermal electric effect is, imagine you have a stick made of some kind of material, and you bring a heat source at one end of or in the middle of the stick. If you measure the voltage potential at the ends of the stick, you will see a voltage difference. So you create an electric current by heating a part of it. Because of the difference in temperatures, there is a certain phenomena that happens, and it creates an electric current. The problem is that in any ordinary material that we know, sooner or later, the heat will go from the place where you apply the heat source to the other end, and the gradient, the temperature gradient will become zero, and the electric current disappears. Graphene has this uncanny ability of not transferring heat, but being a very, very good electricity conductor. And this is one of the very interesting avenues to explore in terms of generating electricity. The only problem is that manufacturing graphene nanotubes is a very, very expensive process, and we don't know how to make it at scale in a way that it can be financially, economically viable. So yeah, I think going forward, the most important thing, and this is something I always militate for, is a more pragmatic approach to energy transition. We're not going to fly on Mars on electric rockets anytime soon. We're still going to use good, tested propulsion based on hydrocarbons. And I would say that is also the case with the way we are going to power the world for the next 2 decades at least. I don't think that the current green revolution that we're seeing in the developed world is going to provide any solution to the energy trilemma of sorts. So energy needs to be first available, then it needs to be produced at a reasonable price point. It needs to be affordable, right? And then it needs to be produced in a sustainable way, ideally not producing an awful lot of carbon dioxide, but it also needs to be generated in a way that it's secure. And I think looking at Russia's example with Germany's energy independence, aerial quotes.
Yes. Yeah.
It's not necessarily the way forward, which is one of the major drawbacks of electricity storage based on lithium-ion batteries, because lithium-ion batteries, they rely on lithium and cobalt as fundamental raw materials, and about 90% of the cobalt reserves are concentrated in one place in the world, which is in Congo, the Democratic Republic of Congo, and those reserves are by and large controlled by China. So it doesn't look very sustainable from a distributed supply chain of the most key ingredient that you need for a battery.
Right. Well, how do you want to put if you have to put it in a perspective of what's happening from a point of all these global corporations who are in this space, right? I mean, governments are talking about net zero targets and also about putting a restriction on selling of diesel vehicles, no more diesel vehicles, no more new diesel vehicles from 2035, which is 12 years from now in Europe. And all these kind of things are happening, and net zero targets are happening. What do you think is happening on the kind of corporations that you are with? How is the thinking there at the leadership? Uh, which direction are they thinking? How are they looking at the whole world?
I think you have a wide spectrum of different attitudes. I think by and large, in the developed world, most corporations agreed to all these aspirational targets, net zero by 2030, then, okay, not 2030, let's make it 2050. Cutting on carbon dioxide emissions every which way. But in reality, when you look at what happens on the ground, we have limitations of what we can do. So the European Union had to go back to the drawing board and re-sign the decision to ban, because remember, initially the European Union wanted to ban internal combustion engines. So cars produced with internal combustion engines of any kind by 2030. Then they had to take it back because obviously there is no practical way, unless you want to curtail any notion of mobility going forward. There is no practical way of doing it. So you see a number of very different approaches. The approach of the main energy providers of the world, and my company is indeed the ultimate energy provider of the world, is by being a lot more pragmatic of what we can do and what we can't do. So, for example, we are investing quite a lot in carbon capture and storage. So we are trying to bring to life real technology that can capture carbon dioxide from the concentrated sources of carbon dioxide, which are basically whenever you burn something, you burn coal or you burn gas or you burn oil in a furnace, the effluent gas that goes up the stack contains concentrated carbon dioxide. There, it makes sense to bring some technology to scrub it from the effluent gas, fix it, and then do something with it. The do something, most of the time, you pipe it and you chuck it back into a geological repository, which is most of the time a depleted oil well. And because we don't have any shortage of oil wells in this part of the world, we are pioneering both capturing, the transportation, and the injection in oil wells. But we also caution people about jumping the gun and thinking we can run the world without fossil fuels for the next 2 decades, because we're not going to do it. So I think that provides a little bit of an answer. You have different companies that are investing in other sources of energy. I think Total Energy is a good example, and Saudi Aramco. We are also, while we are maintaining that it's paramount to continue exploring and bringing on stream fossil fuels as the only way to ensure the sustainability and the going forward as mankind. We're also investing in nuclear power. We're investing in renewable energy. We are investing in making hydrogen, and we're investing in fixing carbon from the sources where fixing makes sense. But in each of these initiatives, you need to be able to tell facts from fiction, because, let's take the last example with carbon capture and storage. I was speaking at a conference last month, and one of the speakers was making a big case for what we call DAC, direct air capture. Now, direct air capture is a fantastic fallacy of our energy transition world. It's basically about capturing carbon dioxide from the atmosphere. So you put a device in your backyard, and that device will filter the carbon dioxide from the ambient air and will transform it into carbon dioxide, pure carbon dioxide gas that you can store in a cylinder, and eventually you can do something with it, inject it into a reservoir, and hopefully stays there, or use it to manufacture some kind of product. Now, that, as I said, it's a wonderful fallacy because it makes absolutely no sense. It's a technological and engineering nonsense that's big as Dallas. And I couldn't resist when I was animating also a panel on carbon dioxide, on carbon capture and storage, and I mentioned the fact that we have a time-tested method of fixing carbon dioxide from the air, and it's called planting trees. And planting trees has an yield, an energetic yield, for the same amount of carbon fixing, which is 5 orders of magnitude compared to what direct air capture is having. So, this is a fantastic example of something that receives quite a lot of attention and a lot of funding in Europe, but makes absolutely no sense. Waste of money, waste of effort, waste of everything.
Adrian, listening to you on this, it sounds like this conversation could have happened even 20 years ago.
Oh,
right?
yes, absolutely.
So
actually, this conversation could have happened 30 years ago, when, unfortunately, Europe decided to abandon nuclear power. Could have happened 20 years ago, when Germany enshrined bad policymaking into law and dismantled their entire nuclear energy. Yes, indeed.
So we pretty much in a status quo.
Yes, we are. Yes, we are. The fundamental problem is that there are limitations every which way we look. And these kind of limitations have been with mankind since dawn of time. But we always used our intelligence to find ways of pushing back the boundaries that confined our society. Now we're getting to the point where the energy conundrum, we have to deal with it. And this is the most complex problem we have ever faced. There is no such thing as an energy poor rich nation. There is a very good image that puts on a 2x2 matrix all the countries in the world, and you can clearly see the amount of energy each country uses and consumes and their GDP. So although, we always learn in statistics that correlation doesn't mean causation, there is a direct, formidable link between the amount of energy a nation produces on a per capita basis and the amount of energy a nation consumes and the economic output of that nation, which is linked to what I mentioned before, that article in Financial Times 2 weeks ago or whenever it was, mentioning that Germany is going through a deindustrialization because they are not able to generate enough energy to power their economy.
Okay, as gloomy as it sounds, we will get Adrian back to talk about his perspective on the future, and hopefully, he did give a lot of optimistic things, that there are some things happening, but only aspect is that the possibilities are not as near as we would like to have it. So with that, I would please go ahead, share this conversation with everybody, and most important thing is just remember what Adrian said, that it's always important that we filter out the noise and be more realistic about it, and which is what is necessary in call of the hour as well. And use the energy more prudently, and follow future fast, and come back to the hear the future perspectives from Adrian Blanck. Thank you once again. And Adrian, thank you so much.
Thank you very much.
I don't have words to say. Thank you.
Thank you. It was a pleasure.